A symbol having a fixed numerical value is called a constant. Basically all kind of numbers. So 2, 3, minus 3, 2 by 5, 5 by 3, root 7, 73, all. So any number that you see is basically a constant. Why is it called constant? Because the number can't change. So if I am telling you that bring 25 bananas from the shop, so you need to bring 25 bananas. But if I say for example, I tell you that bring any 5 fruits from the market. Now 5 is a constant, but fruit can be a banana, can be a mango, can be a mix. You can bring me one banana, you can bring me one banana plus 2 apples plus 2 oranges. So have you understood what I said? So 5 is a number which doesn't change, it is called a constant. And then you will have something called a variable. Variable. Variable is basically, in easy terms, it is the alphabet part. So for example, if you see something like 5x yz square, so 5 is a constant, while x, y, z, the English alphabet part, they are the variables. And why they are called variables? Because they can take any value. So for example, in this 5x yz square, so if I put a value of, say for example, I put a value of x is equal to 1, y is equal to 2, and z is equal to 0. And that is why I'm, again and again saying that x, y, z square, the alphabet part, the English part of any term in algebra, it can take any value. So for example, if in this case z becomes 0, this whole becomes 0. Have you understood what I said? Why? Because this would be 5 into 1 into 2. Shabash, shabash, shabash. This will become 0. So we know that the term is 5x, y, z square. Now we don't know the value which x, y, z can take. If one of these takes a value of 0, the whole of the term will become 0. But 5 is a constant, and x, y, z square, they are using this word literal. But when we'll be discussing algebra, I'll be using this part. So I'll be saying that x, y, z is a variable. Variable implies it can take any value as per the requirement. So for example, in physics, you will have which formula do you know in physics? So for example, you have this formula, density is equal to mass per unit volume. You would have done this. Have you done this? Any formula? Okay, let me take this. So for example, distance is equal to speed into time. This you would have done. Maybe not in physics, but in maths you would have done. So this formula, distance is equal to speed into time, this can be written as d is equal to st. Now in this case, d is equal to st. Distance can take any term, any value. Speed can take any value. T can take any value. Have you understood what I'm saying? So in this case, this dst, they are variables. Variable implies that you don't know the value which they can take. So for example, just for example, in this case, if speed is 5 km per hour and time is 1 hour, then distance would take a value of 5 km. Have you understood? So distance is equal to speed into time is, in this case, the dst. All the three are variables. You don't know the value which they can take. Yeah. Are we clear? So these are the two most important terms which would be used in algebra. One would be the constant. The second would be the variable. Or in this book they have used a word literal. You can skip using this word because I'll be using this variable term again. Any doubt in that? Okay. Now what is the algebraic expression? A combination of constant and variables connected by operation plus, minus, multiply, divide is known as the algebraic expression. So for example, this is a combination of variables and constants. So this full bunch is called an algebraic expression. Any doubt? Now comes the important part. Several parts of algebraic expression separated by plus or minus sign are called terms of the expression. What this means is that, for example, I have something like 3xyz square plus 2xy plus 3k square plus 5. Now this is a combination of lot of variables and lot of constants. But what you need to understand very clearly is that this algebraic expression consists of 1, 2, 3, 4 terms. This you need to understand. That the symbol that separates, any symbol that separates terms are separated by plus and minus only. So for example, if they write something like 5xy square, then you have only one term because there is no separation, no other terms are there. There is no other plus 5 or plus 5 minus 5y square plus k. So those things are not there. So this algebraic expression consists of 4 terms. Are we clear?
Yes.
Yeah. Now once we are clear with this, then we can have different type of algebraic expression. So if our algebraic expression has only one term, so if you see these have only one terms, so they are called monomials. If there are 2 terms, then it would be a binomial. And if there are 3 terms, then this would be a trinomial. Is there any doubt there? Okay. But then nobody stops us from saying 2x x plus 2y minus 3z plus 7z square plus 6g plus 7tf. I can have an algebraic expression like this also. Nobody stops me. Yeah. So how many terms it has? 1, 2, 3, 4, 5, 6. It has 6 terms. Any doubt in there? Yeah. So after 3 terms, they don't give any special name. All they say is that this type of expression would be called a multinomial. Any doubt in there? So an algebraic expression which has more than 3 terms is called a multinomial.
Polynomial?
So polynomial is something different. Yeah. Are we clear till here? So an algebraic expression can have 1 term, 2 terms, 3 terms, 4 terms, 5 terms, any number of terms, and all the terms, they would be separated by a plus or a minus. They are different terms. Are we clear till here? Yeah. Okay. So now from that algebraic expression, I pick out a term. So from this algebraic expression, say for example, from this algebraic expression that they have written here, this algebraic expression they have written here, a square b minus 3b square c, I pick this term. Let me pick this term. And I start analyzing this term, 3b square c. So this minus 3b square c, what does it imply? It implies that minus 3 is multiplied by a b, is multiplied by a b, is multiplied by a c. Have you understood this? This minus 3 b c or minus 3 b square c, they are called the factors of a term. Any doubt till here? So if you see factors of a term, this is the same like saying that the factors of 25 can be 1 and 25. Factors of 100 can be 1, 2, 5, 10, 25, 50, 100. Any doubt till here? So for example, numbers can have factors. Similarly, the terms can also have factors. Clearly? Okay. And then in that, in a term, you can have. Okay. So first they are saying what is a constant term. So a constant term is something. In an algebraic expression, a term which has no literal factor is called a constant term. So what is a literal factor? Literal is basically a variable. So what they are saying is that in an algebraic expression like this, if you see one of the term having no variable, then it will be called a constant term. Any doubt in it? Then we come to what they are saying about coefficient. Any factor of a term is called a coefficient of the product of all the remaining factors. So what does this mean? This means, so for example, uh, take a term like minus 9y square z. Any factor of a term is called coefficient of the product of the remaining factors. So for example, if I ask you what is the coefficient of y square z. So what they are saying, any factor of a term is called a coefficient of product of all the remaining factors. So the coefficient of y square z would be minus 9. Any doubt? If I ask you what is the coefficient of minus 9, you will say the coefficient is y square z. Any doubt? So this is what is called coefficient. And the coefficients, In a term, the numeric factor attached to the variable is called the numerical coefficient. So the numeric part, so for example, in this case, this minus 9 is the numeric coefficient, and this y square z would be called the literal coefficient or the variable. See, very simply, what you will be using again and again would be, so for example, I am writing 7xyz square. Now very simply, this 7 is called the numeric coefficient, and this xyz square would be the variable part or variable coefficient. Are we clear here? Okay, nice. And now we come to the critical definition, like terms. Now the maximum confusion of students would be in like terms. So let us try to understand what are like terms. So for example, first we'll see the definition. The terms having same literal coefficients. Basically, the variable part, the variable part should be the same. So for example, if I have something like 7xy square, 2xy, 3y, 5z square, minus 23 y square x, minus 10 yx, 101 y, and minus 23 z square. So these are the different terms which are given to me. And somebody tells me, I'm sorry.
Yeah.
So somebody asks me, so what are the like terms? So if I have to select the like terms would be 7xy square. See, this xy square and this xy square x, they are the same. Any doubt about this? So these two are like terms. Similarly, 2xy and minus 10yx are like terms. 3y and 101y are like terms, and 5z square and minus 23z square are like terms. Any doubt? See, why this like term becomes very critical for us. It becomes very important for us. So for example, if we had a question like this, and that is why this is important, and that is why maximum confusion would be occurring here. So we'll spend 5 minutes to understand how this works. So for example, I have an algebraic expression like this. Only like terms can be added or subtracted to or from each other. So for example, if I have to solve this, then this can only be added or subtracted to this. So this would be minus 16xy square. Have you understood what I said? Then I'll have to pick up the next like term. 2xy can only be subtracted from minus 10yx. It won't talk to anybody else. A like term for addition or subtraction purposes will only talk to another like term. So plus 2xy minus 10yx would be minus 8xy. 3y plus 101y would be 104y. 5z square minus 23 would be minus 18z square. Have you understood?
Yeah.
Now here is where the confusion lies. Now I'll give you another example. We won't be spending much time on it, but I'll just give you another example. So for example, if the question was that 7xy square multiplied by 2xy. Now both of these are unlike terms.
Because of the square.
Yes, because one of them is xy square, the other is xy. So these are unlike terms. Now they can't be added or subtracted to each other, but they can be multiplied with one another.
Division.
Division is also okay. So unlike terms can't be added or subtracted. They can be multiplied or divided. Like terms can be added, subtracted, multiplied, divided. The root cause of all the confusion that you will ever have in algebra would be regarding these like terms. So that is why I wanted to spend some time explaining to you all the definitions. Any doubt in here? Now, when we are multiplying, we will only be, the numeric part would be multiplied separately, and the variable part would be multiplied separately. Have you done indices? You haven't done indices in school? Okay, so don't worry. But this x at x would be equal to x square, and this y square and y would be equal to y cube. You may not understand this because you haven't done indices.
The y is only 1.
Why? Actually, rules of indices are required. So we'll do indices, don't worry. But I think what you would have understood is that x into x is x square. That part you would have understood. Are we okay till here? So have you understood what are like terms and unlike terms? Have you understood that like terms can be added, subtracted, multiplied, divided with each other? But unlike terms can only be multiplied and divided. They can't be added or subtracted from each other. Are we clear till here? Okay. Are we clear till here that xy square is same as saying y square x? Are we okay? Yeah. These are small things which once you are clear, they will help you a lot. Otherwise, so for example, addition and subtraction is still okay, but when you come to the multiplication part and the dividing part, which is part of this chapter, a lot of confusion arises. Now, let us understand what is a polynomial. Now, a polynomial is basically an algebraic expression in which the variables involved have only non-negative integral powers. So don't worry. Basically, all they are saying is that the x, y, z, k, m, n, whatever variable is there in the algebraic expression can only take values as 0, 1, 2, 3, 4, 5, 6. It can't be minus and it can't be a fraction. We'll be taking example, don't worry. But all that means is x can take a value of 7, y can take a value of 0, this can take a value of 3, 2, 1. This is not allowed. And k raised to power 3 by 2 is also not. You have to be non-negative and you have to be integer. You know what are integers are? Yeah. So basically you can, in a polynomial, x raised to power something or y raised to power something or m raised to power something or n raised to power something would always be raised to power 0 or raised to power 1, 2, 3, 4, 5, 6, 7. Now let us take a few examples so that you understand this well. Okay. So if you see, this is a 3, 2, 1 and here there is an invisible a raised to power 0. Have you understood this? Anything raised to power 0 is 1. Always remember this. So a variable raised to the power 0 is 1. We'll be doing indices. There we'll be discussing this in detail, don't worry. But for, right now for our purposes. So for example, now if you look at this, here x is raised to power some fraction. So that is why this algebraic expression won't be a polynomial. Have you understood? Do you know that 1 upon x can be written as x raised to power minus 1? Do you know this or not? No, it's absolutely okay. No problem. Okay. Root z is written as z raised to power half. Do you know this or not? Don't worry. So this expression z plus 3 z raised to power half plus 9 is not a polynomial because the exponent of z is a half, is a fraction. It can't be fraction. It can't be negative. It has to be a 0. Yes. It either has to be a positive. Basically, it has to be a natural number 1, 2, 3, 4, 5, 6, or it can be 0. It can't be a fraction. It can't be a negative. If it has to be a polynomial. Now, have you understood the difference between a polynomial and a multinomial? Have you understood this? A multinomial is an algebraic expression which has more than 4 terms. But in a polynomial, the variable can take only 0 or natural number as its power.
This can take.
Yes, this can take any nonsense. So for example, see, basically what we need to understand is that all these, basically what the author is trying to tell you is that all these examples that he has taken, 1, 2, 3, 4, 5, 6, all these are algebraic expressions. Yeah. But few of these are polynomials. Have you understood the difference?
Yes.
Yeah. So, for example, in algebraic expression, we did monomial, binomial, trinomial. Similarly, when you come into polynomials, you'll have a linear polynomial, you'll have a quadratic polynomial, a cubic polynomial. Now let us try to understand this. Don't worry. See, the concept that we are discussing right now would be there in 9th class, 10th class, 11th class. So these concepts will keep coming again and again. So don't worry. You'll get a lot of practice. Yeah. But The more clearer our understanding is, the better it is. Algebra becomes a bit simpler if you are comfortable with the definition, or at least you know that the definitions have been discussed. And I'll be sharing this PDF with you. So whenever you feel any confusion about like terms, unlike terms, so whenever we are discussing something and you forget what is a coefficient, what is a variable, what is a polynomial, what is the difference between an algebraic expression and a polynomial, you can refer to the definition or you can refer to this lecture. Any doubt? Okay. Now let us understand what is the degree of a polynomial. What is the degree of a polynomial? So now I have a polynomial. Yeah. The first is in one variable. What does the meaning of one variable means? So for example, I have a algebraic I have a polynomial like 3x square plus 2x plus 7. Another polynomial like 3x square y plus 4y square plus 5z square. So both of these are polynomials because the powers are either 1 or 0. So for example, 7 can be written as x raised to power 0. So the powers of x are 2, 1 and 0 in the first polynomial. And in the second polynomial also, if you see the powers, they are either 2 or they are 1. Any doubt till there? Okay. Now the first polynomial. This polynomial, if you see, it is only in terms of x. This is only in terms of x. But the second polynomial, it has x as well as a y. Do you see this? So one type of polynomial would have only one variable. So for example, another example that you can take is 3k square plus 5k plus 7k cube. Now this has only one variable, which is k. But there can be other type of polynomials where if you see polynomials like these, they have x, xy, x, y square, y square. Or you look at this, these are not polynomials. So x square, y, xy, x cube, y cube. So they have two variables, x and y. Any doubt in there? Okay. So what is the degree of a polynomial? The degree of a polynomial is that first you verify that whether you have a polynomial or not. Once you have verified that yes, this is a polynomial, then you take the term which has the highest exponent. So for example, 3x square plus 2x plus 7, we have verified that this is a polynomial. The term 3x square, in the term 3x square, the highest power of x is 2. Therefore, the degree of whole of this polynomial would be 2. Any doubt? So we can have linear polynomials. If you see, there is a 1 here, so there is a 1 here, there is a 1 here. We can have a quadratic polynomial and we can have a cubic polynomial. Any doubt? So the first step is to verify whether the algebraic expression is a polynomial or not. Once you have verified that yes, this algebraic expression is a polynomial, then you look at all the terms. When you look at all the terms, then what you identify is you take the term which has the highest power, and that would be the degree of whole of the polynomial. So usually we'll have linear polynomials, quadratic polynomials, cubic polynomials, or constant polynomial. A constant polynomial is just a number. Just a number. Why? Because see, 7 by 2 can be written as 7 by 2 x raised to power 0. Anything raised to power 0 is 1. So 7 by 2 can be written as like this also. And this polynomial is called constant polynomial. Any doubt in there? Pakka? We'll be doing questions also. Don't worry. Maybe in the next class we'll do questions also. So if any confusion is there, we'll tackle that also. So degree of a polynomial in two or more variables. Now you have a polynomial which has a x also, y also, maybe a z also. So how do you make out the degree? So what you do is, I'll give you an example. And in the next class, I think we'll spend some time doing questions from these concepts. So for example, you take a polynomial like this. 6x cube minus 2x square y plus xy square minus 3x square y square. Now, of course, this is a polynomial because the exponent of all the variables are either 1 or 2 or 3. So this is verified. But now, what you need to understand is, and because you haven't done indices, you might face some difficulty. The highest power is 3. Here, the highest power is 2 plus 1, 3. The highest power is 3. The highest power is 2 plus 2. So the highest power or exponent of a term in this polynomial is 4. So that is why the degree of whole of this polynomial would be equal to 4. This degree of a polynomial in 2 or more variables is a confusing topic, so don't worry much. Okay? But we should be very clear. Basically, what we should be very clear is we should be able to identify whether this is a polynomial or not. And the second thing, what we should be able to understand is it a linear polynomial or a quadratic polynomial or a cubic polynomial or a constant polynomial. Okay? Now, in the next class you come, we will do these questions. Identify monomials, binomials, trinomials. You'll get some practice in this. Write the numerical and literal coefficient of each of the following terms. In minus 3 x cube y cube, write down the coefficient. Identify the pairs of like terms. Which of the following expressions are polynomials? Write the degree of each of the following polynomial. Write the degree of each of the following polynomial. We'll do question 1 to 7 so that you get enough practice about this concept. Okay. Once you see why I want you to get very comfortable with this is once you understand this, then concepts like addition of like terms, subtraction of like terms, subtraction of polynomials, multiplication of polynomials, division of polynomials. These things will start making sense to you. Otherwise, you'll be very confused. Any doubt? So in the next lecture, we'll do practice questions of this lecture, and we'll try to do a few questions from addition and subtraction also. Yeah.